Hi, good day, friends. Today I am here with another video related to the corrosion only. And in this one, as I have earlier told you guys, today I am going to discuss about the corrosion and its different types. As you can see in here, that types included is uniform corrosion, galvanic corrosion, crevice corrosion, pitting corrosion, then MIC corrosion, erosion corrosion, stress corrosion. So these are the various types which is mostly asked in the exam. So I am going to discuss and what exactly the preventive measures we can do to prevent these corrosions. That also I am going to discuss. Yes, but before starting the different types, first of all, I will just brief you what exactly the corrosion is. Corrosion on board a ship is a gradual destruction of the metal surfaces due to the chemical or electrochemical reactions with the marine environment, and basically the environment is seawater or the salt laden air. So this is going to create a corrosion. Final result is the destruction of metal, failure of material. So this is something which is a point of concern. Basically it weakens the vessel structural integrity, damage the equipments, and it poses also the safety risks if it is not controlled in a proper time, because this is a gradual process. If you give time, it will corrode more and more. Different types of corrosion coming to you. Galvanic corrosion, it occurs when the dissimilar metals, as it is named as a galvanic corrosion, the steel shaft, bronze propeller, that are coming in contact. In other way you can say it's as a bimetallic corrosion also. Pitting corrosion, this is the localized corrosion. It creates the deep hole on the deck platings and the tank walls. Next, crevice corrosion. These are the hidden corrosions inside the joint seals and narrow gaps because it needs the crevices, small passages. Erosion corrosion, this is the metal worn away by the fast moving water common in the propeller and the pumps. Basically the erosion is leading towards corrosion. It is basically removing the protective coating and the bare metal is exposed and the corrosion started. Microbiologically influenced corrosion, this is called MIC, and as the name, it is caused by the bacteria in the ballast tanks and bilges. Stress corrosion cracking, cracks from under tensile stress, as the stress is going to create the cracks, and these cracks remove the protective coating, bare metal exposed, and the corrosion started. Now, in this one, I am going to tell you about the types of corrosion found in the ship and the description, and what are the typical locations. Because sometimes in the question it is also asked where it is found. So uniform corrosion, as it is saying, it's a even rusting across the surfaces and the hull, deck platings, all around the accommodation part also. So it is typical location is that. Galvanic corrosion between two dissimilar metals, propeller shaft and fittings, that is also there. Pitting corrosion, localized deep holes, it is found in the ballast tanks, pipelines, etc. Crevice corrosion, it is in the narrow gaps, riveted joint, seals, or any other joints where the gaps are found. Erosion corrosion, this is being accelerated by the water flow or any cargo flow also, where basically the removal of protective coating is done. Propellers, pumps, pipelines, also this possible. Microbiologically influenced corrosion, this is caused by the bacteria. Ballast tanks and bilges are the most prone for that. And stress corrosion cracking, this is under the stress. Basically cracks created first and then the corrosion happen. Wherever the high stress structures are there, this is going to be found on that. Now you can see that this is the photograph which was in the very first slide. I have already shown you this uniform corrosion all around the ship. It is a even part galvanic corrosion. You can see the different dissimilar metals, like it is shown over here, the steel shaft and the bronze propeller. So these are the two dissimilar metals. So same like other examples are also there. We can have the galvanic corrosion. crevice corrosion. You can see that wherever the fine recesses are there you can see the fine gaps, there the crevices are being formed and the corrosion started. Pitting corrosion, as you can see, the deep pits are found basically on the deck as well as the places where your pit formation occurs. Crevice we have already discussed. Bilges and the ballast tanks are formed with the MIC. Erosion corrosion, anywhere it is being possible, wherever you have the removal of protective coating. And the stress corrosion, the cracks development. So this is the picture which is going to remind you. This is for the understanding of what exactly the corrosion type and where it is being found. Okay. Galvanic corrosion, we have the formation of galvanic cell. You have to remember that. Galvanic corrosion is an electrochemical attack and it is more active, and the formation of anodic and cathodic couples are being done, and it requires the your conductive environment. So like seawater, it is acting as an electrolyte, or any other electrolyte which is basically creating the perfect condition for the formation of galvanic cell. That is your anode formation, cathode formation, and the electrochemical liquid. So this is going to be a part of the galvanic cell, and basically the anode is going to be sacrificed. Galvanic corrosion, basically it is a specific type of corrosion that occurs when two dissimilar metals are electrically connected in the presence of an electrolyte such as seawater, and it is one of the most common form of the corrosion and damaging the ships. Steel shaft, which is acting as a anode, bronze propeller acting as a cathode, and steel will corrode in presence of the seawater. Okay. Here now we can see that this is something which is example how in one metal only, like if we take an example of the deck, we can see over here it is something which is a pit formation. Here you have the anodes. Wherever the pit formation is there, this is the anode, and the rest is acting as a cathode. So cathode will be survived, and the anode will be corroded. And there you can see in the presence of, this is the water droplet, basically a drop of seawater, and it is having the oxygen also. So here you can see the establishment of the corrosion current, and this is something which is a perfect example of the corrosion cell formation. And these small corrosion cells you can see on multiple times on the deck, and you have the pit formation, and this is a continuous process on deck. It is very much evident. So cathodes are getting protected, and the anodes basically are getting uh, sacrificed. So here you can see the oxygen. Here what happens, the H2O reacts with the oxygen and form the 4 OH minus ions. These are the formation of hydroxyl ions, and these ions basically combined with the Fe means that is your MS, mild steel. Okay. So 4OH minus plus 4Fe plus 2O2, it is going to create the rust. That is your 2Fe2O3 H2O. So here the rust is formed between the anode where the free ions are present, and the surface of the water drop where the hydroxyl ions are present. So this also gives you a clear cut idea how the corrosion occurs on the deck. You have the pit formation, cause may be anything, and once the pit formation started, the anode is present, cathode is present, and once the seawater droplet uh, formed on the deck, this process starts. Okay, so required condition and the preventive measures, you can see that here for this corrosion to happen, electrical contact between the dissimilar metal, yes. Presence of electrolyte which is in the form of moisture or seawater, yes. And the potential difference between these two metals, then the galvanic cell formation is the perfect and the corrosion starts. What are the preventive methods? Insulating the metal. You have to insulate. Basically on deck, what we are doing, we are creating the barriers in the form of paint, in the form of coatings, or we can use the sacrificial anodes, zinc or aluminium. Apply protective paints to isolate the surfaces. Select metal which is close in the galvanic series to minimize the potential difference. So this is something which is very important. Now the next is your pitting corrosion. You can see here pitting corrosion is the localized corrosion, and leading to the severe structural damage when the overall surface looks intact. Pitting corrosion is the formation of small deep holes on a metal surface due to the localized attack. Unlike the uniform corrosion, this spreads evenly. Pitting penetrates inward and weaken the metal in a significant manner. So this is something which is an important part. How the pitting corrosion happens? There is something which is a protective film like paint and oxide layer. It is going to protect. But when it breaks down due to the any cause and the small spot or a small pit is being formed, then the problem starts. The chloride ions in seawater concentrate in that area, and then what happens? The pit which is being formed is acting like a miniature electrochemical cell, which we have discussed earlier. I have shown you the diagram also. And this pit grows deeper and deeper while the surrounding surface remains unaffected. So on top you will see it is unaffected, but the pit will go deeper and deeper, and this pit will become anode and rest will become cathode, and the process goes on. And so many multiple pits are being formed on deck, and this is something which is going to cause the corrosion. Pitting corrosion, what are the various locations? Ballast tanks. These are the stagnant seawater where you have the encourages pitting, wherever you have the stagnant waters. Pipelines, especially the seawater cooling lines. I must say the cargo pipelines also, where you have the erosion corrosion as well as the pitting also. Hull plating beneath the biofouling or the damaged paints. That is also possible. Storage tanks where water and salt accumulate, there are also possibility of pitting. What are the various preventive measures? High quality coating and the regular maintenance. With this, you can prevent the pitting corrosion. Next, cathodic protections with the sacrificial anodes or the ICCP also. It is going to help you out. Next, frequent inspections using the ultrasonic and the magnetic particle testing test, where these formations are easily detected and the proper maintenance is being carried out to prevent the corrosion to happen. Material selection, stainless steel which will resist the pitting better than the carbon steel. So, but commercial part also we have to see, stainless steel is very costly as compared to the MS. So wherever is possible, it can be utilized and prevent the corrosion. Now next is your crevice corrosion. What exactly it is? This is something which is another a localized form of corrosion, and wherever the narrow gaps or the shielded areas are being found and the seawater or the moisture becomes trapped and stagnant, this is going to happen. Crevice corrosion is accelerated attack on the metal surfaces inside the confined spaces like joints, seals, or overlaps due to the restricted oxygen supply and stagnant electrolyte. Basically, when we see about this one, this is something which is going to found in the joints, like in between the flanges, wherever the seals are there, wherever you have the overlaps. So if there is fine recess, the water goes inside and then the corrosion starts. So stagnant oxygen supply and the stagnant electrolyte is going to help the crevices or the recesses, the corrosion to start. It is particularly very dangerous for the ships because it develops in the hidden joints and fittings, where normal person cannot see that until unless you have the proper watch keeping or the serious checking of that. Here you can see it is a diagrammatic representation where you can see these are the recesses, and here you have the larger surface that is acting as a cathode, and this is also acting as a cathode, and the recesses where you have the ingress of the seawater or the moisture content. So these area become your anode, and finally what will happen once the corrosion will happen, the destruction of material will happen, and from there you have the cracks developed, and this is something which is going to form as a crevice corrosion. So joints are more vulnerable. You have to keep an eye on that. Here you can see the crevice corrosion part. And the same thing where the corrosion current formation is there, the sodium chloride, it will divide into the sodium plus and the chloride minus ion, and your iron hydroxyl ions are being formed, OH minus, H plus, and here you have the axon of that, and this flow of current, this is the anodic part, and this is your rust which is being formed over here. Okay, so this creates a passive film also on top of that. So this is a very enlarged view of the crevice corrosion which I have given you, and you can understand it better. How it happens: a small gap is formed, crevice traps the seawater, oxygen goes inside, and the corrosion is started. And this difference creates the formation of electrochemical cell. Inside the crevice, it is becoming anodic, and outside the crevice, it becomes cathodic, as I have shown you. And cathode gets protected, and anode gets sacrificed. So this is something which is a crevice corrosion. How you can found these locations: riveted joints, bolted joints, seals and the gaskets, overlapping plates, rope and barnacle arrangements for the hull plating, under deposits of dirts, biofoulings or the paint blisters. So these are the various places where you can found these crevice corrosions. Flanges and all, that is all I have already discussed. Here you can see design improvements. What are the various design improvements? Avoid tight crevices where it is possible, so you have no recess. Seal the joints properly, welding instead of riveting. Now it is all welding. Protective coating to block seawater entry. Yes, you should not allow this. Then the corrosion cell will not form. Regular cleaning to remove deposits and biofoulings. Yes, it is required. And cathodic protection, which is found in the tank and hull areas, that is also a part. Okay. Okay, so I'm stopping here as the video goes very long. So I'm continuing with the same thing in part 2. Okay, so in this one, I hope all of you have understood the early explanation of the corrosion, as well as the various types, and some of the types like crevice corrosion, the pitting corrosion, galvanic corrosion, I have explained to you, and their preventive measures, locations found on ships. Okay, so I'm coming with the next video with the remaining one. Thank you.